Good morning, students. Today we are going to start double integral and triple integral. In double integral dx dy, when we integrate with respect to x, we keep y as constant. And in double integral, if we integrate with respect to y, then we have to keep x as constant, same like we do in partial differentiation. In triple integral, in one more variable at in triple integral, we have dx, dy, and dz. In triple integral, if we have dx, dy, dz, in first of all, we integrate with this. When we integrate with respect to x, we have to keep y and z as constant. And then next integral, when we integrate with respect to y, when we integrate with respect to y, we have to keep z as constant. And then we have integrate with respect to z. Our final answer comes out to be constant. Final answer comes out to be constant. Now we discuss about limits. In triple integral, when we integrate with respect to x, this limit may be variable or constant. This limit may be variable or constant. When we integrate with respect to x, in case of variable limit comes in y or z. Now, when we integrate with respect to y, then this limit may be constant, may be variable. But in case of variable, this limit must be variable z, as we are not only with z. And with respect to z, when we integrate with respect to z, this limit must be always constant, so that we get constant answer. This limit is with first variable, this limit is with second variable, this limit is with third variable. Remember one thing, when limits are given in triple integral or double integral, you have to take that variable first. You have to integrate first with that variable which has maximum variables. Like if x is a function of if x limits of x
Hello, ma'am.
are in terms
Hello.
of y and z, two variables are present, so we integrate with respect to x. And if limits of y is in terms of z, here one variable is present, so we take it as second limit. And when various limits of that are in constant, we have to take it as third variable. dx, dy, dz. Order is material only when limits are given. If suppose all three dx, dy, dz, all these three variables have constant limits, then what to do? We can write this triple integral as product of three single integral. We can write this triple integral, or we can write double integral as a product of two variables, and in triple integral product of three integrals as limits are independent. If limits are constant, limits are independent, we can separately do integral three times. Rather than doing combined, we can different integral, and on integrating we can multiply the result, and result always comes out to be constant. Now with the help of one example, this thing we can make it clear with the help of one example. Now see one example. Evaluate integral 0 to 1, integral 0 to under root 1 minus x square, integral 0 to under root 1 minus x square minus y square. These all three are limits. Function is 1 upon under root of 1 minus x square minus y square minus z square dx dz dy dx. Now, see in this question, first of all, we have to integrate back to z. So x is treated as constant, y is also treated as constant. 1 is also constant. See, we have to integrate first with respect to z here, then we integrate with respect to z. X is constant, y is constant, z is constant, function. So 1 x to y are constant and z is variable. So we have of that formula which is constant and justified formula will be represented. See how we solve or how we think of in this type of question. The solution. Given I equals to 0 to 1, 0 to under root of 1 minus x square, 0 to under root of 1 minus x square minus y square, 1 upon 1 minus x square minus y square minus z square, dz, dy, and dx. This is given as. We know one formula in plus 2, if you remember, integral of 1 upon under root of a square minus x square dx. We know its value is sine inverse x upon t. Here we have to integrate this back to that, so only that variable, and this one is constant. I can write it as here or here. I can write under root of, I will write 1 minus y square as here whole square root and whole square, as here and square root get cancelled out. Why I have like that? Because I want the integral of under root of a square minus x square is sine inverse x upon a. So I will get integral 0 to 1, integral 0 to under root of 1 minus x square, integral 0 to 1 minus x square minus y square, these all are limits, into 1 upon under root of 1 minus x square minus y square whole square minus z square dz dy. First of all, we consider only this thing. We integrate it as single integral. Triple integral is basically doing single integral, which we do in plus 2, but it is 3 times. We have to do it 3 times. And if it's double integral, we have to solve it 2 times. It is nothing but simplifying single integral again and again. Now, you can forget these two limits and divide that. Just think of this limit and this function and this event. Now, I know if I integral of 1 over under root of a square minus x square is sine inverse x upon a. So, I will write its value over here. What I will have 0 to 1, 0 to 1 minus x square. And when we integrate it, this limits of integral comes to right hand side similarly as we do in 12th standard. What I will get sine inverse z upon a. Here a is under root of 1 minus x square minus. Limits from this side, what I will get 0 till 1 minus x square minus y square dy and dx. I know it is clear to all of you. Now next step is fill limit. Simply fill upper limit minus lower limit. How? Instead of that, see how we can solve it. 0 to 1, 0 to under root of 1. Sine inverse, when you put this limit over here, both will become the same, so it can cancel out, and you left only with sine inverse 1 minus lower limit. And when you put 0 instead of that, 0 or something is 0, you will get sine inverse 0 and dy dx. Now simplify these limits. Sine inverse 1, we know its value is pi by 2. Sine inverse 0, it is 0. So pi by 2, this is pi by 2, this is 0. Pi by 2 minus 0 is pi by 2. So I will get integral 0 to under root of 1 minus x square. Here it will become pi by 2 and pi dx because its value is pi by 2, its value is 0. Now we can take constant outside from the integral. Constant outside from the integral. Now I have to calculate again this single integral. This I have to integrate this single integral as 12 standard. It's very easy. Very, very easy. Like what we do in plus 2, we are doing same but 2 times or 3 times and nothing else. Now what we will get? Pi by 2 already outside. Now integral dy as we have been in plus 2 standard. Now we know integral of dy and limits come on right hand side. What we get? 0 to under root of 1 minus x square dx. Next step, we already know upper limit minus lower limit. So we get pi by 2 integral 0 to 1. Now instead of pi, we have to put under root of 1 minus x square minus lower limit. So minus 0. Under root 1 minus x square minus 0 is under root of 1 minus x square and here it is dx. Now we have to use the formula integral under root of a square minus x square dx. What is its formula? As in plus 2 standard, we have made this value is x minus under root of a square minus x square plus a square by 2 sine inverse x by a. So putting this formula in the integral. Now, using this formula here, what we will get? I will get pi by 2 is outside and inside. Apply this formula and we get x by 2 under root of a square. Here a is 1. A square minus x square plus a square by 2. Here a is 1 by 2 sine inverse x upon a. A is 1 and limits comes on right hand side. Now, using upper limit minus lower limit, what you will get 5. Now put 1. When you put 1 minus 1, 0. Okay, sine inverse 1. 1 by 2, sine inverse 1 by 1 is sine. This is upper limit. Now minus lower limit. Now 0. 0 into something. This becomes 0 plus sine inverse 0. Sine inverse 0 is again 0. So pi by 2, 1 by 2, it will become pi by 2 and sine inverse 1. Pi by 4 and sine inverse 1. We know the value of sine inverse 1. It is pi by 2. So answer comes out to be pi square by 8, which is required answer. I hope it is clear to all of you. Now moving on, next question. Remember one, if you know formula of integration, you can solve the because we have to do simple integration. But when variable increases like 3 variable or 2 variable, but we always do single integral. Only there is double or triple integral. In double integral, there are 2 types of questions. In first type, limit is already given and we have to just integrate. And the second type, function is given and we have to find limits by r. In the same way, in triple integral, we have 2 types of questions. In first type, integral is given with limit and in second type, function is given and we have to find limits by ourselves. Now, in first example, integral is given with limits, but in this question, function is given, but limits are not given, and we have to find limits by ourselves. See this question, evaluate triple integral dx dy z upon x plus 5 plus z plus 1 whole cube over the tetrahedron bounded by the coordinate. So remember, coordinate are when x equals to 0, y equals to 0, and z equals to 0. I repeat, x equals to 0, y equals to 0, and z equals to 0. This is given to you. And one more thing, x plus y plus z equals to 1. If you remember, prism used in practical is tetrahedron. Pyramids are also example of tetrahedron. One more thing you have to know, the coordinate are x equals to 0, y equals to 0, and z equals to 0. In this question, given I equals to, if I write over here, solution I start over given I equals this triple integral. See, here limits are not given, limits have to find by keep one limit as constant, one as variable. In the same way, or same process is followed in triple check. Here we have three variables. So treat one variable as constant. I repeat, treat one variable as constant. Second is single variable, and third is double variable. It's our choice which variable as what. No cramming, it is simple concept. Here I is given and here B is the region. You can write B where B X, Y, Z. The region bounded by the bounded by the coordinate plane. You can mention coordinate plane over here to overcome confusion. X equals to 0, y equals to z equals to 0. And the x plus y plus z equals to 0. I have started. Now, next step is to find limit. Now, for finding limit, treat x as constant. When you have to treat x as constant, what you have to do is for it, y equals to 0, z equals to 0. And you will get value of x as 1. I repeat, y equals to 0, z equals to 0. In this equation, put y 0, z 0. What will get x plus 0 plus 0 equals to 1? Means x equals to 1. And starting limit of x is 0. So you will get constant limits of x from 0 to 1. Try to keep limit of x as constant, then y in one variable and then z in double variable. Okay. So starting value of x is 0, therefore limit of x is from 0 to 1. Means if you draw diagram of coordinate plane, if x is 0, x is 1 over plus 4, means when you have taken limit of x from 0 to 1, you have covered this one sequence. But we have covered whole tetrahedron. For it, you have to take second variable in the form of double variable and then third in the form of one variable. You have to keep like this way x as constant. So you can write b as limits of b as b equals to x comma y comma z. Now we have to find y. When we put x in terms of y, again I draw a diagram, bigger diagram, clear the concept. Suppose this is x, suppose this is your y, suppose this is your z. Origin. Origin means 0, 0, 0. When you have taken the limit of x from suppose this is 1, then you take limit, if you take limit of x from 0 to 1, you have covered this. Now, when you take y in terms of x, in that case, you have covered this one sequence. If you want to take y in terms of x, what you have to do is put z equals to 0. Put z equals to 0. In equation x plus 5 plus 5 equals 0. Now put z equals to 0. Get x plus 5 equals to 1 and 1 minus And in coordinate plane, x0, y0, z0 means starting limit of y is 0. So you will get limit of y from 0 to 1 minus x in this way. When we put x in terms of y, then we covered this much portion. We have covered only this much portion on putting x in terms of y. So we will get limit of y from 0 to 1 minus x. Now, next step is when we put z in terms of x and y. See, z in terms of x and y. In that case, we have covered this figure or this portion. Actually, we want to cover whole tetrahedron. We want to cover whole tetrahedron. Means when we put that in the xy. So in that case, from that here, what you will get that 1 minus x minus y. So we will get limit outside minus 5. I hope it is clear to all of you. Which variable we want to keep constant and which variable we want to keep as variable with 14 hours. In actual y for that when you y over that we will get x equals to 1. So limit of x from down to 1. Next we put only z. Next we put only z is 0 in x plus y for that equals to 1. In we get x plus y equals to 1 or y equals to 1 minus x. Therefore, range of y will be from 1 minus x. And in last, value of z will be z equals to 1 minus x minus y. In this case, simply take x by term of y. And you will get z equals to 1 minus x minus y. Starting limit of 4 is 0. In this way, we have covered and diagram will be this. Diagram will be this. If you want to take all the limits from y in terms of x or z in terms of x and y, then in that case, here is one, here is one. If you think you can take x limit of x from 0 to 1, limit of x from 0 to 1. What you have to take the range of x, y, z is from 0 to 1. But we can't consider all limits constant. Why? So we covered only the lines. This is the line. This is the line. And again, this is a line. But it is not tetrahedron. Why? Because tetrahedron is a three-dimensional structure. So we have to cover all its lines. And if we take limit of x, y, and z from 0 to 1, then we have covered only lines. But we kept the central structure. So we have covered the reason we keep one limit as constant and remaining limit as variable. Fourth is we keep x as constant from 1 and then take limit of y in terms of x. If we take limit of y in terms of x, then we cover this much. We have covered this much portion or this much reason. Now we take into that. Now we cover these two portions. We completely covered 3D structure. So we take x from 0 to 1, y from 0 to 1 minus x, z from 0 to 1 minus x minus y. So in any portion, when you have the 3D structure, always take Mostly we take x as constant, y and z in terms of x. You can take constant according to your choice, but commonly used pattern is take x as constant, y in terms of x, z in terms of x and y. Do you remember the constant also? We consider that x and y. We always treat that as a function of x and y. In plus 2 class, we always consider y as a function of x. Same pattern we follow here. We always consider x as an independent function. We represent y and z in terms of x. So, what we get that our integral I becomes, therefore I becomes 0 to 1, 0 to 1 minus x, 0 to 1 minus x minus y, and function x plus y plus x plus 1 whole cube dz by and x. Always write that first which contains maximum variable. Then that which contains comparatively less variable. And at last write variable. Always remember this order. Don't do any mistake while writing limits. Until you don't find the order exact right does not matter. Don't remember this order until limit is not given. Follow the order only when limit is given. Otherwise, we never follow order. Limit is not given. Always follow order according to given limit. Now, first of all, in aggregate that we know integration is not possible in denominator. We can't integrate. So, bring function in numerator. When you bring function in numerator, what you will get in next step, you will get integral 0 to 1, integral 0 to 1 minus x, integral 0 to 1 minus x. Bring the function in numerator, the power is 3 in numerator. And limit is dz, dy, dx. Now we have to integrate first with z, then with y, and then with x. Same as we do in single integration. Simply, so first when you integrate with respect to z, you know the formula x raised to power n integral. What you will get x raised to power n plus 1 upon n plus 1. I write over here integral a plus z raised to power n. This formula is a plus z raised to power n plus 1. So same formula we use over here. I will get x plus y plus z plus 1. 4 is minus 3 plus 1. I will get minus 2. So divided this is minus 2. Limits come on right hand side. 0 to 1 minus x minus y. Then dy and dx. Next step is upper limit minus lower limit. Next step is put z equals to this. I will get 0 to 1 minus. When you put z equals to 1 minus x minus y, x and y will cancel out. And we are left only with 1 plus 1 plus minus 2. minus constant outside from the integral as we move in plus to plus. And when you put that equals to 0, when you put minus over limit that equals to 0, you will get x plus 5 plus 1 raised to power 1 and b by dx. Now, next step is to integrate with respect to y as we have done with z. Now we integrate with respect to y. What I will get when I integrate with respect to y? Integral minus 1 outside. Now this is 1 plus 1. This is 2. First of all, I simplify this thing. First of all, I simplify this thing. 1 plus 1, it is, and 2 is 1 minus. Means 1 upon 2 square, and 1 upon 2 square is 1 by 4. As we have to integrate by, so we keep it in numerator. One by 4 is constant and divided with 1 by 4 and integral is 5. Integral of dy is 5. So here y and as of dy is 5. And here integral of n same formula. You will get n plus 1 upon n plus 1 minus 2 plus 1 minus 1 upon minus 1. Limits come on right hand side. And next is left over here. Next step is upper limit minus lower limit. Next step is upper limit minus lower limit. First of all, y equals to minus x. You will get 1 times x minus. When you put y equals to 1 minus x, x and x get cancelled out, and we are left only with 1 plus 1. Here this minus and this minus become plus. 1 plus 1 raised to power minus 1. This is upper limit. Now, lower limit. You can place it in 1 bracket. This is upper limit 1. Now, lower limit. For lower limit, you have to put 0 or something. 0. Minus, minus, plus. When we put y now, we are left with 1 plus x. 1 plus x raised to power minus 1, and here it is dx. Now we know integral of 1 by x dx. It is log x. Integral of 1 by x dx is log x. First of all, when we simplify it, 1 by 4, 1 minus x, 4, 1 by 4, 1 minus x. Plus 1 plus 1 is 2, x power is minus 1, and 1 by 2 minus 0 plus something something, so its power is minus 1. It is denominator. This is lower limit. dx. Note, if any term has power it is denominator, we call it the formula. Integral of 1 by x log x plus c. Next integration is very simple. Simply we can write it as minus 1 by 2 outside, x equals 0 to 1. 1 minus x into 1 by 4. We can write it as 1 minus x upon 4 plus 2 raised to power minus 1. Cos 1 plus 1 is Now we have to integrate back to x. We want to combine the constant together. I can write 1 by 4. Separate it. 1 minus x by 4 as 1 by 4 minus x by 4. Power minus 1 becomes plus 1 in denominator. And this minus 1 we take it in denominator, then power becomes 1. Now this 1 by 4 and 1 by 2 not taking LCM, we get 3 by 4. And this is minus x by 2 and 1 upon x plus 1. Now this dx will look at when we integrate dx, we will get integral of dxl x. Now x is equal to n. We know this formula x is equal to n plus 1 over n plus 1. 4 into 2 it will become 8. 1 upon function log of function. So this becomes log of function. And limit will come out from that equation. Now x equals to 1. In upper limit, you will get 3 by 4 and minus 1 by 4 and so on. When you put x equals to 0, it becomes 0, 0, 0. 0 minus 0 minus 1. So when you take the LCM of these two, you get 1 by 8. When you open the bracket, the negative bracket will become positive, you will get 1 by 2 log 2 and minus 1 by 16, which is required answer, and hope it is clear to all of you.